Hello, welcome to everyone in this video. In this video, I want to discuss about the solution of on the thermal physics, that is CC6 paper of Calcutta University third semester on the year 2021. At first, we can see the question paper in 2021 for semester 3 Calcutta University physics honors. You can see this is question number 1, then question number 2, question number 3, 4, 5, 6 and 7. I request all of you at first you try to solve this question, that is question number 1, 2, 3, 4, 5, 6 and 7. After that continue the video towards the solution, right? First question says, what is the necessary to introduce the concept of quasi-static process in thermodynamics? Quasi-static process means when a process changes. Suppose you have any thermodynamics process that is from point state A to state B. Now we can change this process very small. The change is like that, very small, such that its initial and final state change is very small. You can see here written the quasi-static process is like that. Sorry, there is a mistake. Where is this PDF? This is the PDF. Okay, this is technical fault. We can't do anything about this technical fault. We just wait a time. Just so quasi-static process is like that, the process in which the two step in is very close to each other. That's mean you can see their change is very small or negligible. Change is negligible. Okay, so wait for the opening for the PowerPoint. Just a minute. Just there is a okay. Sorry for this inconvenience. This was not good for this. Okay. Finally you obtain this step. So this already omitted this portion. I just say this is very small step. We take this step is very small. Okay, this step is very small. So here written, a quasi-static process is idealized process which involve infinitesimal changes in the thermodynamic coordinate of a system as compared to the absolute value of the coordinate. That's mean here the point state change from A point to B point with the step is very close to each other. Okay, this is the infinite quasi-static process. It is necessary to introduce the concept of quasi-static process in thermodynamics because we are considering things to be ideal in a particular thermodynamic system. If our system change rapidly, we would not able to decide where we should start our calculation from. So we assume the system is quasi-static process. That means when we change abruptly, there is no equation follow up. So we need to change small, very small, such that we can calculate each step. Okay, or you can say is another need. You can say that is irreversible process can be converted into reversible process by quasi-static process. Irreversible process can be converted into reversible process by introducing quasi-static process. static process, by quasi-static process. Okay, so I think clear. Next question, explain why the specific heat of gas at constant pressure is greater than that at constant volume. In case of gas, there is two specific heat, that is specific heat at constant pressure and specific heat at constant volume, because when we apply the heat within the gas, they change its temperature with their change its volume as well as pressure. So we cannot measure exact increasing in temperature. That's why you need to fixed any of one, that is pressure or volume. That's why there is two specific heat at constant pressure and constant volume. Now if you say that for constant volume du is the 0, so only dq used as CVDT. When pressure is constant, then dq has two part, that is du and pdv, and there is no 0. So CPDT, that is constant pressure specific heat, have two components, Cv with some other part. So you can see Cp is greater than Cv. Okay. So in theoretical, here is written that the work done on the gas increasing internal energy of the system at the constant pressure when its gas is heated, work done is overcome to the pressure. There is an expansion of the volume with the increasing in internal energy of the system. So there is two part in case of constant pressure, whereas in case of constant volume only one part, because the dv part is 0, so dq is only du. Next question says explain the perpetual motion machine is not possible according to thermodynamics. In the first law of thermodynamics, the law is conservation of energy. So it states that energy always conserved. To keep the machine moving, the energy applied should be stay with the machine without any loss, because its fact alone. So it is impossible to build perpetual motion machine. So automatically a machine is act or it run out. So this is impossible. According to the first law of thermodynamics, he says the conservation of energy, which says the conservation of energy. So this will not possible. Next question, prove that the adiabatic elasticity of a gas is gamma times the isothermal elasticity, where gamma is the ratio of the specific heat of gas Cp by Cv. So adiabatic elastic Es is minus V del P by del V at constant S. S is the entropy. And isothermal elasticity Et is minus V del P by del V at constant T temperature. So their ratio will be like that. If we change the variable is this, we know the formula. So we just change this del P by del T and so on. And after using the Maxwell, these are the four Maxwell relation, you know, these are the four Maxwell relation, thermodynamics relation, Maxwell thermodynamics relation. Using here you can get Cp by Cp. Okay, so Es equals to gamma Et. Next question says prove that the relation, that is du del u, prove that the relation, that is del u del v at constant T is equals to T del P by del T at constant V volume minus P. So from the first law of thermodynamics, you know that is dq equals to du plus dw, that is the change in internal energy, and dw is the work done. And from the second law of thermodynamics, dq equals to T ds. T is the temperature, ds is the change in entropy. So their combination dq can be written as TdS. So TdS equals to du plus PdV. Now you taking with respect to volume, partial derivative with respect to volume, will be get ls del v, del u del v, and this is dv dv 1. So p. Now using this Maxwell relation here, you just easily find out this proof. Okay, relation. Next question. At what temperature will root mean square speed of oxygen molecule be double its value at Ntp while pressure remain constant? So root mean square speed relation is root under 3 RT by m. Hence there is no change in mass or R is the constant, gas constant. So only depends on temperature. So you can see T2 is equals to this is the double, so their square is 4 T1. So in terms of in Entropy, the temperature in Kelvin scale 293. So this is the in Kelvin, and in degree centigrade 899 degrees centigrade. So at 899 degrees centigrade, Newton mean square of oxygen is double at the entropy. Next question, draw the pressure temperature diagram of H2O, that is the water molecule integrating the phase boundary at the triple point. Actually, in case of water, the slope of this boundary between liquid and solid state is like that, whereas in wax or others will be like that. So this is the difference, basic difference in case of, this is for the water, this is for water, H2O, this is for water. Okay. So these are the gaseous phase, liquid phase, solid phase, and they are transition zone is boundaries, and this point is known as triple point, where 3 state coincidence here. So 3 state coincident here is the triple point, and these are the boundary, that is the transition between two zones. Okay. So the state is only, does not only depends on temperature, it is also depend on the pressure around this region. Next question says, a Carnot engine operates between temperature T1 and T2 with a gas as working substance whose equation is like that. So this is the equation of this gas, and their heat absorption and work done in the part of the cyclic. So in the efficiency will be like that. So in Carnot cycle, we know there is 4 process cyclically, isothermal expansion, then adiabatic expansion, then isothermal compression, then adiabatic compression. This AB is isothermal expansion, then BC is adiabatic expansion, then CD is isothermal compression, and then DA is the adiabatic compression. Now the heat absorbed during the AB part will be PdV. So P is can be find out that RT by V minus B. So if you just put P equals to RT by V minus B here and integrating, you can easily find out the Q1 value. Similarly for Q2, that is ejected heat from the isothermal compression here, and put their value here, W equals to their separation. So efficiency will be like that. Now take these 2 points, that is the BC and DA, which are adiabatic process, and in case of adiabatic process, you know the relation T V to the power gamma equal to constant. So V is here V minus B. So put this relation, this is for adiabatic expansion, and for adiabatic compression, DA is the adiabatic compression, not expansion. So this will be compression, adiabatic compression. In case of adiabatic compression, the relation will be like that. If you comparing equation 2 and 3, you will be obtain this relation and use this relation in the previous expression of eta. This is the efficiency, you will be just obtain this relation. So this is normal, like just like in theoretical class we already discussed this relation, just equation is different. Okay, but final relation is the same. I think clear. If there is any doubt, you must comment in the comment box. Next question, give the Kelvin Planck statement, Clausius statement in second law of thermodynamics, establish equivalence of statement. We already discussed in this in theoretical class. We just take from this slide, that is Kelvin Planck statement says there is no such cyclic process that it take heat from the source and totally convert in work done. So this is not possible. No cyclic process exists, that is no other effect than extraction of heat body and convert into equivalent amount of mechanical work. So these total heat taken from the hotter body and converted into total work done, this is not possible by Kelvin Planck statement. Clausius statement says there is exists no cyclic process which has sole effect of the transfer of heat from the colder body to hotter body. It says that the heat taken from the cold body, that is temperature is lower, and eject to the hotter body without other effect. So this is also not possible. Okay. So this can be two equivalence, that is these are the negative statement, both are negative statement. So truth of Kelvin statement and false of Kelvin statement can be taken as minus k if this is k. Truth of Clausius is c, then minus c is the false. So k will be equivalent to Kelvin Planck statement will be equivalent to Clausius statement if Clausius statement imply to Kelvin statement imply the Clausius statement and Clausius imply to Kelvin. Otherwise, minus Clausius implies to minus Kelvin, or minus Kelvin Clausius implies to minus Clausius. So these or these implies these two are equivalent. So for that we just first prove that minus k implies that minus c. For this we can say this is minus k means here this statement says this cannot possible, minus k means this is possible. So this violate the Kelvin Planck, that is minus k. So consider the engine EQ1 take from some source T1 and reject no other colder body. Okay, so there is no violation. This is possible Q2 W and this one. So their combination will be like that, and this can say this Q2 taken here and Q2 eject. So this is the violation of Clausius, that is minus C. Similarly, this is written here. You can just look at this note. And similarly for minus C imply minus K, minus C means from sink, this is sink, you know, this is sink and this is source. So from sink it will take Q2 amount of heat and reject towards the source, and there is no violation. This is normal engine where Q1 take from the source, some eject to the sink, and this is the work done. So their combination will be like that. You can see there is no other effect than it just work done taking heat from the source. So this is the violation of Kelvin Planck. So violation of Kelvin Planck, minus Kelvin implies the minus C and minus C implies the minus K. So this is two are equivalent. So I think clear about these things, and this is written here. You can just look out these things and just take the note. Next question says, so that the efficiency of this process is like that. Efficiency is nothing but the work done by W by Q1, work done by input heat. So here the W is the work, area of this circle or ellipse, or Q1 is the area of this portion, that is the under the area. This total area will be the Q1, and this portion only, this area of the circle only W. So just find out this area from the geometrical expression and put this value. Okay, so in case of Q1 there is two part, that is the semicircle and this is the rectangle. The area of semicircle half pi radius square, radius is BD, half of BD, and this is the rectangle. Okay, so find out this value, and similarly work done is the area of the circle, pi into radius square, radius is BD by 2 whole square, that's why this 4 arise, and they are put this value W and Q1, finally obtain this relation. Next question says, so that the probability of a gas molecule traversing a distance x without collision is e to the power minus x by lambda, where lambda is the mean free path of the gas molecule. Consider a system having a large number of molecules N0 at a given instant and a follow group as the molecule collide. Let n be the number of molecules reaching after a distance x. Then from this probability function will be like that, and integrating and put this initial value will be obtain this relation, and mean free path will be find out here 1 by Pc. So this will gives you like that. So I think clear. Next, find out the expression of the most probable velocity Cm and number of molecule and having the most probable speed, and plot this graph. So this is the Maxwell distribution law, DNC, that is the number of particle having the speed between c and c plus dc. What is DNC? Number of particle having the speed between c and c plus dc. number of particle having speed between c and c plus dc. This is the dnc. Okay, so this is formula is 4 pi n aq e to the power minus b c square dc, where a is root under b by pi and b is m by root m by 2 kbt. Okay, so the at most probable velocity the first derivative of this expression will be 0. Taking the first derivative, we will be obtain cm equal to root under 2 kbt by m, and this number of molecules, if you just put c as cm, you will be obtain this expression. Okay, and the corresponding graph will be like that. You can see with increasing temperature the number of particles will be reduced and the corresponding most probable speed will be increased. That's why the peak height is reduced but the peak position will be increased here. Okay, so this is the plot. Next question say, why isotropic distribution of particle is needed to be derive the Maxwell velocity distribution. Actually, the Maxwell velocity distribution of molecules spherically symmetrical. The density of the representative points is the same everywhere on the sphere of the radius c in velocity space, the isotropic distribution. That's why isotropic distribution of the particle is needed to be derived the Maxwell velocity distribution. Next, why Brownian motion is observed below the definite size of particle. Actually, Brownian motion observed it below definite size of particle because if particle size is large, then the motion due to impact of fluid mechanics or fluid molecules is rather than the low velocity small free path. For the small particle, the number of impact comparatively small and the prevent fast in a direction and another become noticeable. Okay, so just take note of this question. Next, find out the now degree of freedom. Find what happened again, something will be find the number degree of freedom for H2O water molecule and carbon dioxide molecule assuming linear combination of molecule. So there is water molecules, so for that number of atom n3 constant, so this is 6, and for that degree of freedom is 7. State the equipartition of energy and establish the relation between degree of freedom and the ratio of source specific heat. The equipartition of energy is the total energy of any system equally distributed along each degree of freedom and with the value half kBT, where kB is the Boltzmann constant, it is the temperature in Kelvin scale. Consider Na is the number of molecule with degree of freedom F. The total energy of the system will be half kBT is the for every degree of freedom. For F degree of freedom, this is the energy and this for number of molecules. So Na into kB is R. Then specific heat at constant volume Cv equals to del U del T, that is half Fr, and Cp minus Cv equals to R, so Cp equals to this one. If you divided this thing, you will be obtain this relation, gamma equals to 2 by F. Gamma is the ratio of the specific heat at gas, that is the Cp by Cv, and F is the degree of freedom. Next question says, so that the real van der Waals gas equation Cp minus Cv equals to this one. This already discussed in theoretical class, that is in van der Waals equation, if you take both sides, differentiate with respect to temperature, you will be obtain this relation. Again P equals to this, put this value, and Cp minus Cv equals to this one. After putting this value, you will be obtain this relation. So that the isentropic transformation, this is happen. So this is the Cp minus Cv expression. The past law of thermodynamics TdS equation is like that. For isentropic equation, ds equals to 0. From here Cv will be obtained and put Cp Cv by Cp minus Cv, just obtain this relation. Next, assuming the relation T ds equals to Cp dt minus T del V del T at constant P dP. So that for isothermal compression, delta Q equals to minus Tb alpha P2 minus P1, where delta Q is the heat transfer where fluid compressed isothermally from pressure P1 to P2. Alpha is the coefficient of volume expansion. So this is the TdS relation. Coefficient of volume expansion is like that. Put this expression within this one, and finally you obtain this relation. Next, for a living system, aging process can be stopped which thermodynamic law support, second law of thermodynamic law support this. Okay. Next question say using Clausius theorem, so that for any process Sm minus Si greater than equals to integration I to f dq by dt, where symbols have their usual meaning. So this is the Clausius theorem we already discussed in theoretical class, that is any system perform this relation, this will be less than equals to 0, equal to is for reversible, and any other process this is less than. And entropy definition will be obtained from here. Here you can write there is process R, this is another reversible, and IR is the reversible process. So if you take this reversible process, have this separation will be like that, and this is the increases entropy, the internal irreversible changes. This is for reversible change. So this is greater than this one. Okay. Next, apply suitable transformation of enthalpy. Actually, we did not find out any solution of this question. If anyone can do this, you must comment in the comment box. Next, using the Clausius-Claperoyn equation, investigation the possibility of latent heat to be 0. This is the Clausius-Claperoyn equation. So if L will be 0, this will become 0. That's mean at the point that is the triple point. At the triple point, L can be 0. Deduce the expression for the amount of cooling of paramagnetic substance by adiabatic demagnetization. So dq equal to TdS. For adiabatic, this is 0, and for magnetic material, the equation of first law, combination of first law second will be like that, and dt will be this one. So negative sign is signify the demagnetization, and this is the negative for paramagnetic material, hence dt is less than 0. So adiabatic demagnetization of material always led to drop in temperature. In the other expression, you can just use Curie's law, you will be finally obtain there is negative, that is with demagnetization the material temperature will be reduced. Next, the specific volume of the water 0 degree increased by 0.91%. So actually use this Clausius-Claperoyn equation and put this value, you will be obtain this result. Next, prove the enthalpy, that is H equals to del G by T del 1 by T at constant volume, where G is the Gibbs energy. So the enthalpy will be this one, and the Gibbs energy equal to this one, Cu plus Pv is H. So H equals to G plus Ts, and S is del G by del T. So taking the minus T square as a common, this one, and this is nothing but del T of G by T. So this gives you the proof. So I think clear about this question solution. If there is any doubt, you must comment in the comment box. This is all about me, and this is my contact details, and this is my YouTube channel. So take care. We will meet in the next video as soon as possible. Thank you.